Hello everyone. Today we are going to discuss data replication algorithms. First of all, we will see the concept of data replication. So whenever you are considering replicas or multiple copies, creation and their maintenance across various storage locations or systems, then there comes the concept of data replication. So it involves creation of duplicate copies considering the information from a source location which is considered as the primary or master copy, and we are considering the creation of it into one or more secondary copies. These secondary copies are stored on separate servers or data centers, or even on various systems which are located on the geographical different locations. Now we will consider the various benefits of data replication. As you can see diagrammatically, it is having the benefit of availability and redundancy, performance and scalability, disaster recovery, load balancing, consistency and integrity. We will discuss these benefits in brief. Considering the data availability and redundancy, if the primary copy becomes unavailable due to the hardware failures or network issues or disasters, then we are considering its replicas for storing the required data and for maintaining the continuity of the ongoing operations. Here, the replication will help to ensure that you are having the accessibility of data even in the phase of failures. Data replication also improves the performance and scalability. The replication will enhance read performance. It will distribute the data across multiple locations. Client can retrieve from the nearest or the most suitable replica, which will reduce the latency and improve the response times. Also, replicas will enable the scaling of read operations by allowing multiple servers to serve data concurrently. It is again beneficial for the disaster recovery and business continuity. If any particular disaster happens, then the replicas will be used for the quick restore of data and you can resume the operations. Replication will allow the data for the geographical distributed systems and will protect against the localized failures. You can consider the data replication for load balancing and performance optimization. When you are considering the read and write operations, we are distributing them amongst the multiple processors as multiple copies to ensure the load balancing. It will help to distribute the workload and will prevent any individual replica to become a performance bottleneck. By distributing the load, replication will help enhance the overall system performance and to consider the resource utilization. Again, we can have the benefit of data consistency and integrity if you are considering the data replication. The updates to the primary copy are propagated to the secondary copies, which will ensure that all replicas remain synchronized and up to date. The techniques like synchronous or asynchronous replication can be employed based on the desired consistency, which will guarantee the performance improvement and will handle the trade-offs. There are three main data replication algorithms. It is single leader, multi-leader replication and leaderless replication. Again, for this single leader, it is having two categories: synchronous, asynchronous. Multi-leader having two categories: synchronous, asynchronous, and leaderless having the asynchronous replication. We will see in brief about these three data replication algorithms. Firstly, the single leader replication. It is also termed as the primary, secondary, active, passive, or master slave replication. Here the replication can either be synchronous or asynchronous, as we have just now discussed. When you are considering the multi-leader replication, there will be the use of many leaders which will replicate the data to their followers. The replication again will be either synchronous or asynchronous. Lastly, the leaderless replication. As the name implies, there will be no individual leader here. Each node is responsible for both read and write in the leaderless replication, and leaderless replication can't be the synchronous. Reason is it will consider the fundamental changes and trade-offs with achieving the synchronous replication in leaderless environments. Diagrammatically, we can represent single leader replication as this. You can see here the client or the user will request for the right operation to the leader. As it is the single leader, it will provide the request from the client to the n number of followers, and each follower will work on the request and will provide the read response to the client at end. So as we have seen earlier in the diagrammatic representation, there will be only one designated leader node in the single leader replication who is responsible for handling all the write operations. The leader node will receive the write request from the client, will process it, and will ensure that the replication of data is done at the follower nodes. The follower nodes will replicate the data from the leader and will handle the read operations. So this kind of replication is ensuring the strong consistency and will make sure that all write operations are serialized, applied in the same order on all the replicas. One drawback will be leader will become the bottleneck and will impact the write throughput. In case the leader fails, there will be the failure for the durability of data. Next, multi-leader replication. You can see here for the multi-leader replication, it is having two data centers and it is having the multiple leaders considered for each data center. We are considering the changes or replicas prepared by the leader and will transfer to the followers. So here each data center will consider a individual leader, and that individual leader will create the replicas and will transfer the changes or updations to the followers, and then the followers will do the task and will give the output to the particular client about the read and write operations. So here, as we have seen earlier, in the multi-leader replication, there are multiple leader nodes. Everyone is responsible for handling the subset of write operations. Each leader node will have its own set of follower nodes. These are the follower nodes for a particular leader. And these follower nodes are used for replicating the data from that specific leader. The write operations can be directed to any of the leader nodes, and the updates are asynchronously propagated to the respective followers. Here the benefits will be improvement in the write scalability, and it will consider the reduction in the write latency, as the write operations are processed concurrently by multiple leaders. Also, it will be helpful for managing the conflicts and will ensure the data consistency across multiple leaders. Lastly is the leaderless replication. As you can see here, there is only a single or a end user client having its read and write request, and they are transmitted to the replicas directly without considering any particular leader involvement. So here the followers or the multiple replicas will perform the read and write operations for a single user requests. This leaderless replication is not having any designated leader node, as we have just now discussed, and there will be the coordination of write operations by just the follower nodes. So here all the nodes in the system will participate in the replication process and will handle both the read and write operations. Here each node will act autonomously and is independent. It will make the decisions about the data replication and the conflict resolution. For this data replication algorithms, I have referenced this particular link. Thank you all.